Hello and welcome back to Math Class with Mr. Kura. Today we're going to be talking about how to identify a linear equation and compare it to something that's nonlinear. We're going to look at it as a graph, as a table, or as an equation. The first and easiest is looking at a graph. So first of all, what does linear mean? So linear means a straight line, things, data, points, something like that, arranged in a straight line. Which means, so if it's a straight line, it means it's increasing by the same amount over the same time or distance. It has a constant rate of increase. Now, how do you tell if a graph is linear? Well, the same thing. Is it a straight line? You ask yourself, you look at this graph and say, is this a straight line? If it's a straight line, it's linear. If it's not a straight line, if there's any sort of curve or any change of direction to it, it is not linear. It is what we call non-linear. Non-linear. If it's a straight line, that means it has a constant rate, and it is called linear. So all of these are linear. I'll do it in a different color here. Linear. These are all linear. Straight line, no change in direction. Straight line, no change in direction. No change in direction. No change in direction. These all have a change in direction or a curve to them. It doesn't have to be a curve. It could be a point, like something like that. Your graph could have a pointed change of direction, but all these are called non-linear. So that's how simple it is to tell if something is linear or non-linear in a graph. Now, in a table, so there's a few ways to tell, given a table, if it's linear or not. Once again, we talked about, does it have a constant rate of return? Is it increasing by the same amount? We can also, in this one, we're given some ordered pairs. So let's try and plot those ordered pairs and see what happens. So the first one, I'm going to start with the lowest x value. So -2, 5. I go -2 up 1, 2, 3, 4, 5, and then I go 2, 1, 2, 3. Next one's 5, 1, 2, 3, 4, 5, down 2. So already right there I can tell I can't draw a straight line and connect those three. But here's 7, 4 would be right here. So there's no way I could draw a straight line and connect those. So that would be what we call non-linear. So if you're given a table, you can plot them. Later on, we can also talk about how you can look at the table and check them. For now, we're just going to look at graphing them. Okay, we can do the same thing with ordered pairs. This is a table is basically ordered pairs, right? Just in a different format. It looks different. So let's plot these. So 0, 1, 2, 3, 4, 1, 6, 2, 8, 3, 10. So those are a straight line. I can connect them, make a straight line. Now this one was pretty easy to tell as I was graphing them that it was going to be linear, right? Because my x value was increasing by 1, plus 1, plus 1. As my x value was increasing by 1, my y value was increasing by 2. So it was a constant rate. It was increasing by the same amount. All right, last thing. Now, if we look at an equation, how do we tell if an equation is linear? Remember, it has to be y equals mx plus b. So there's a couple things we look for. If we, because some of these aren't quite so obvious, right? If we ever have a variable, so x or y raised to a power, that is non-linear. That is not linear. That means there would be some sort of change in direction if it's raised to a power. So as I go through this, right away here I see this one's x squared, so I know that's non-linear. That's the only variable that I see raised to a power. The other thing is if we see a variable in the bottom of a fraction, or if a variable is a denominator. There's only one fraction, and this one is a variable as our denominator, so that one's no. If we meet those two criteria, or if we would say answer no to both of those questions, is there an exponent with a variable with an exponent, or is there a variable as a denominator? If we can say no to both those questions, then they're linear. So yes, yes, these are both going to be straight lines. This one would just be a straight horizontal line somewhere on the graph. This one would be kind of a diagonal or a line that's increasing like that, but they would both be straight. All right, thanks again for spending time in math class with Mr. Kura, and I look forward to talking to you again soon.